This is the beginning of the next unit. Trig ratios, tangent, sine, and cosine. Look at these. The definitions are on the top of your paper. All of these words refer to angles. It's going to be the sine of an angle, the cosine of an angle, the tangent of an angle. These are abbreviations. Where it says sin, don't say sin. It still is sine. It's just short for sine. So don't say, oh, sin A, sin B. That's rookie mistakes. Okay? It's not sin. It's still sine. All right? COS is still cosine. TAN is still tangent. Say the word, even though it says the letters, TAN. All right? Now, you have to understand what these definitions mean, though, because we're going to be using these till the end of this semester. When I say opposite leg, opposite means across from. Okay? As opposed to adjacent, which means next to. All right? Opposite means across from. Adjacent means right next to. So if you had any question about that, go ahead and write that down. All right? Opposite is across from. Adjacent means right next to. All right? And of course, you know what the hypotenuse is. Okay, so for example, look at problem number 1. We're supposed to find the sine of angle x. All right, these are always going to be angles. So sine of angle x. That means you have to look at angle x. The answers will change depending on which angle you're looking at. So Chase, look at angle x. Now, what's the definition of sine? Look at the formulas at the top of the paper. What's the definition?
Leg over hypotenuse.
Right. Sine is the opposite leg over the hypotenuse. Okay? Now, obviously, which part of this triangle is the hypotenuse, class?
The 37.
The 37 is the hypotenuse. I'm going to go ahead and highlight that because that's not going to change. That's the hypotenuse. It's across from the 90-degree angle. We know that's the hypotenuse. So the question is, so far we know that in the bottom of the fraction is going to be 37 because that's the hypotenuse. So the question is, which is the opposite leg? So looking at the x, which I just circled, all right, the opposite is going to be the leg that's across from this, the one that's further away. So which leg is across from x, 12 or 35?
35.
35 is across from x. So when I say opposite over hypotenuse, I mean the 35 over 37. So that's it. That's the answer number 1. Just fraction. Simple. All right, the directions just say to write it as a fraction and a decimal rounded to 4 decimal places. So go ahead and do 35 divided by 37 in your calculator and tell me the decimal to 4 decimal places. 0.9459.
Yeah.
Okay, so that would be the answer to problem number 1. Let's do problem number 2. The minute you understand, start working ahead of me.
0.324.
Okay, so cosine of angle x. So now we're doing cosine. The definition of cosine is adjacent over hypotenuse. All right, the hypotenuse is still 37, so that still goes in the bottom. Adjacent means right next to. So looking at angle x, now what's right next to it? The 12. So this one will be 12 over 37, which as a decimal would be point what?
3243.
0.3243. If you round it.
Okay, it says 4 decimal places. Okay, 0.3243. Okay, now tangent. Switch back to red. What's the definition of tangent?
Opposite leg over adjacent.
Opposite leg over adjacent leg. So this time we're not dealing with the 37 at all. But be careful, something changed. The last 2 problems dealt with angle x. This time we're changing our perspective and we're looking at angle y. Okay, so from the perspective of angle y, which leg is opposite angle y?
12.
The 12 is opposite because it's across from the y. So the angle matters. So it's going to be 12 over. Which leg is adjacent next to?
35.
Then the 35 is adjacent. See how close it is? So opposite over adjacent, that's 12 over 35. Or
0.3429. You round.
okay? So that's how you do that. Let's keep going. Sine of angle A. So we're looking at angle A. Sine is opposite over hypotenuse. So what's opposite?
8.
8. What's the hypotenuse?
17.
17. So 8 over 17. I'm going to leave you guys to make the decimal on your own so I can get to the bottom problems. I trust you can make your own decimal. Cosine of angle A. Cosine is adjacent over hypotenuse. So what's adjacent?
15.
The 15. So that would be 15 over 17. The nearby leg divided by the hypotenuse. Okay? The homework is on the shelf. If anybody that didn't get the homework, it's on the shelf for you. And then tangent of angle B. So again, it changes things when you look at the other angle. All right, so I had to switch to angle B now. Tangent is opposite over adjacent. Opposite leg over adjacent leg. So looking at angle B, what's opposite?
15.
The 15 is the opposite leg from angle B because it's across from angle B. What's the adjacent leg?
17.
17 is the hypotenuse. 8, okay? So be careful. Only use the hypotenuse when the formula says hypotenuse. Okay? When we say opposite and adjacent, we're talking about the legs, not the hypotenuse. All right? And I'll trust you guys to make the decimals on your own for those. Now, the main object of that was to set us up to be able to solve things like 7 through 10. Okay. Now, when we're talking about tangent, sine, and cosine, we are talking about angles. What's the one angle that you're given in number 7?
40 degrees.
You're given 40 degrees.
And 90 degrees.
So, right, the 90 degrees, just don't even look at that. Okay? Look at the small angles. So, look at these problems that we've done. Sine x, cosine x, sine y. Those letters were always the angle. But this time we have an actual number instead of just a letter. So looking at this 40 degrees, look at the two things that I've got labeled. I've got this x and I've got this 22. Are either of those the hypotenuse?
Yes.
What's the hypotenuse here?
22.
So I've got myself a hypotenuse. Now, look at the x. The remaining choices are opposite or adjacent. Now, is looking at the 40 degrees, because it's all about the angle, is this x opposite or adjacent?
Opposite.
It is opposite, because remember, opposite means away from, across from. So, I've got, from the perspective of the 40, I've got opposite and hypotenuse. Look back at your functions. Look back at your formulas. Which one involves opposite leg and hypotenuse? Say sine. Don't say sin, say sine. Okay, if you look at those formulas, you see that it is the sine function that involves opposite and hypotenuse. That's how we know that we're going to use the sine function right now. So everybody do this. Write sine, but instead of a letter, put 40. Sine 40 equals. Now make your fraction. Opposite over hypotenuse. So that's going to be x over 22.
That's our answer.
Okay? No, we got to get x by itself. Now, look, sine 40, that's just a decimal. Your calculator can generate that. Don't worry about that yet. But sine 40 is like a thing. It's its own thing.
Oh, that's what.
How will I get rid of the 22, though? I need to get x by itself.
Well, you gotta
I'm going to do what, Matt? Multiply by what, Matt? I'm going to multiply both sides by 22. So everybody do this. Times 22 times 22. That way these 22s are going to cancel each other out. Okay? Now look what I have. I'm just going to recopy to make it really clear. So far I've got 22 sine 40 equals x. Just leave it just like that. 22 sine 40 equals x. Now go to your TI-30XS multiview and just type that in. Type in 22 sine 40 and see what you get. Right, so we did 22 sine 40. And we got 14 point, how many decimals does it say? Does it say?
No.
It says the nearest tenth, so 1 decimal. So x equals 14.1. Okay, and that's how you do it. Let's see if we can get one more in. Look at number 8.
Okay, Mr. Burton.
Okay? Looking at number 8, 35 is the angle. 34 is opposite. And x is the hypotenuse. So which function is this again?
Cosine.
It's sine again. Because it's opposite and hypotenuse. That's
I
sine.
was looking at X.
No, we look at the 35 degrees.
I'm tripping.
Okay? So sine of 35 is equal to 34 over x. Now the question is, how do we get this x by itself? Okay? Now we could, no, the 35 and the sine, they're stuck together like glue. Okay? Let me give you a shortcut that you're going to see me use over and over again. Watch this, guys, shortcut. The x and the sine 35, you can switch places.
No, you cannot.
Watch this. So this would become x equals 34 over sine 35.
You said they were.
You can always swap those. The denominator and the thing that's by itself, you can swap those. So then you could just put that in your calculator. Okay, so you can go 34 over sine 35. Bam, 59.3. All right, we're going to have to leave it there.
What's that?
59.4.
Over sine.
Wait, I got a question. Is 9 and 10, are you still sine?
All right, now look at number 9. What do you see? Starting from the 25-degree angle, we've got the 18, and we've got the x. Which one of these is the hypotenuse? All right, of course, the x here is the hypotenuse. All right, that leaves the 18. From the perspective of the 25, is this 18 opposite or is it adjacent? See how the 18 is right next to the 25? That means this one is adjacent. So you have to ask yourself, which function is this? Which function involves adjacent and hypotenuse? So if you look at the formulas that we have, opposite, hypotenuse, adjacent, hypotenuse, cosine. So that's what tells us that we're going to use cosine on problem number 9. So we will use cosine. So cosine of 25 is equal to adjacent leg over the hypotenuse. So that's 18 over x. Now, remember the shortcut that I just showed you on problem number 8. Anytime you have x in the denominator like this, a shortcut is you can take the side that's by itself and swap it with the x in the denominator. You can always do that. I mean, just in general, like say if I have p over q equals n. Anytime you have a fraction equal to a single number, you can always take the denominator and the number that's by itself and swap them. So we would get P over N is equal to Q. Okay, you can always switch those. So remember, treat this cosine 25, treat that as a single thing. So when I do this switch, I'm going to get x equals 18 over cosine 25. And you can just put that in your calculator. So we'll do 18 over cosine, what was it? 25. So that gives us 19.9 if I round to the nearest tenth. So that gives me x is equal to 19.9. Alright, last problem, number 10. Let's make some space here. Okay, so this time, again, looking at the 50, the 12 is the hypotenuse, and the x is adjacent. So again, we have adjacent and hypotenuse. So again, if you check the formulas, adjacent and hypotenuse, that's the cosine function. So that tells us that we're going to use the cosine function. So we write cosine of 50 equals adjacent over hypotenuse. So all we have to do is get x by itself. How are we going to get x by itself? We need to multiply both sides by 12. Alright, that way those 12s will cancel each other out. So that gives us that 12 cosine 50 equals x. So again, I can just put this in my calculator. So we get 7.7. Okay, so x equals 7.7. And that's how it's done. I apologize for the noise. This is my freshman support class, so they're not really paying attention to this lesson, but they had finished their test early, and I wanted to use the time. But that's why it's so loud. The kids are just they've already finished their test. It's basically study hall at this point.